Hi, my name is Gassan and I'm the team lead Group 3G. The team has shown true dedication and put in an incredible amount of work, which is why I'm pleased to introduce the Smart Solar Panel System.
The smart solar panel will rotate in the direction of the LDR that is receiving the most amount of light.
Due to there being 4 LDRs, one at each corner of the solar panel frame, the Raspberry Pi code will compare the voltage at each LDR since light hitting an LDR causes its voltage to decrease. The servo motors will only stop rotating if the LDRs are at a position in which the solar panel is receiving the maximum amount of light available.
For the purpose of proof of concept throughout this demonstration, a flashlight is used to represent the movement of the sun.
The system is first turned on, the solar panel is set to be in automatic mode. As you can see, as the flashlight is moved from left to right or up or down, the solar panel tracks it. However, since the LDRs produce an analog output, an ADC was required. Specifically, an MCP3008 was selected as it uses SPI interface which is compatible with the Pi. When the user selects manual mode, the system shifts to respond to the user input either from the potentiometer or the arrows in the GUI.
In order to measure voltage, current, and power from the solar panel, an external device was needed as the Raspberry Pi does not have a built-in ADC.
The INA219 was chosen as it can make all 3 measurements and serially sends the data back to the Pi via the I2C bus. The INA219 uses a 0.1 ohm shunt resistor between the VN plus and VN minus terminals to measure voltage and current. Voltage is measured directly by comparing the voltage at VN plus to ground. Current is measured indirectly by reading the voltage drop across the shunt resistor and then using I equals V over R to calculate the current through the resistor. Since the resistor of the shunt is so small, it can be treated as negligible and the circuit can be seen as unloaded, meaning the current leaving the solar panel will not be limited. The power is calculated by simply multiplying the current and voltage together. This information is then serially transmitted back to the Pi via the I2C bus to be used in plots shown in the GUI.
The support system is made up of a wooden U-frame and a wooden base to support the U-frame.
The wooden base has a cut at the bottom of it for the horizontal servo motor to sit in. Similarly, the U-frame has a cut on one side for the vertical servo motor to sit in. On the other side of the U-frame, there is a screw which will hold, support and balance the solar panel as it rotates vertically. To eliminate friction when the horizontal servo motor rotates, there are 2 metal washers sitting between the U-frame and the base. When designing the support system, the team considered factors such as weight, mobility and strength. Along the course of the project, the team went through a number of iterations when designing the support system, but were able to arrive at one that was easy to implement and meet all of our requirements.
In order to provide the user with better control over the solar panel, a graphical user interface was developed.
The user interface allows the user to view data from the solar panel using the INA229, such as current, voltage, and power in the form of plots. It also allows the user to view environmental data such as temperature and humidity in the form of floating bars using a DHT22 sensor. In addition, the interface allows the user to have control over the motor system, being able to switch between the 2 modes, manual and automatic. With the manual controls, it uses 4 push buttons to rotate the solar panel in the desired direction.
The graphical user interface has 2 tabs that offer various functionalities to the user. The Weather tab has an external option that launches the weather in the area of interest in a web browser. Similarly, the Charts tab has power, voltage, and current options. Whenever either one is selected, a LaTeX script is run to generate a PDF of the plots for offline usage. And that is the Smart Solar Panel System.